which it will show up on YouTube as comedy, in case any of you weren't aware of that. For some reason, my math instructional videos are classified as comedy. I don't know why, but they are. It's not like I'm lying. It's real math, but whatever. Okay, the natural numbers. These are simply, and again, this is review, so I'm going to go fairly quickly through it. The natural numbers are the counting numbers. If I ask you all to count with me like we were in grade 3, we would start with what number? 1. So that's the first natural number. The natural numbers are what we count as 1, 2, 3, up to infinity. Can we ever get to infinity? No. Please notice 1, 2, 3. There's a problem with this, because how many numbers really exist between number 1 and number 2? Infinity, right? There is an infinite amount of numbers between 1 and 2. But when we count, we go 1, 2, right? So this has no decimals or fractions. That is what you need to remember. All right. Whole numbers. These are the naturals plus 0. 0, 1, 2, 3, up to infinity. And the same rules apply. The third one, integers. They are the whole numbers. Yep, whole numbers plus negatives. Negative infinity, negative 1, negative 2, other way around, idiot, not you, me. 1, 2, up to positive infinity. And again, the rules continue. That is where it ends. And all of you already know this. The reason we talk about these now, we make a big deal out of it, is because we use math to model real life. And in real life, there are times when you can't use a fraction. Right? You just can't. If we are doing a graph of the amount of people in the room, could we have a fraction? No, because half a person cannot walk into the room. Even if someone missing both legs were to roll in on a wheelchair, they are still a whole person. Okay? That is why we do this. Now, these two are where the rules change slightly. Rational numbers are all fractions. But there's some rules. They have to be written like this, and x and y must be integers. And y cannot equal 0. You're not allowed to have 0 on the bottom of a fraction, and x and y have to be an integer if you're a rational number. That's 1, 2, all repeating or terminating decimals. And you all already know this. If you don't need to write it all down, you don't need to write it all down. Those are the easy ones. Irrational numbers are, of course, everything else. Pi, because pi doesn't repeat or terminate. The square root of 2, the square root of 3, the square root of any number that doesn't fit into that. Those are all irrational. You all already know about pi. There's a bunch of other ones that are famous. We don't use them in Pre-Calc 11, but you will use them in the future, in future math courses. Okay? Now, sometimes it gets a little weird. For example, the square root of 2.25. That looks irrational, but it is not, because that is the square root of 225 over 100, which is 15 over 10, which is 3 halves. That's okay. But the square root of 22.5 is irrational because it will not end or terminate. Is everybody good with this very quick review of the number system? The reason, again, I am doing it is because sometimes you will make graphs that you cannot use some of the numbers on it. Everybody okay? Which, of course, leads me to my favorite math joke of all time. The number pi and the square root of a negative number. They meet in the streets. And the square root of the negative number gets mad and he tells pi to be rational. Get it? Because pi's irrational. And then pi gets mad and he tells the square root of a negative number to get real. Because there's no such thing as a square root of a negative number. Get it? Math jokes for everybody. You can laugh now. They're funny. All right. But you hear the one about the two atoms that met?
Yeah.
No, you didn't. What is it? I know. One atom says to the other atom, I lost an electron. The other atom says, oh my God, are you positive? You can all laugh. They're funny. Ah! When does the chemistry teacher tell jokes? Periodically. Periodically. That's even better. You're all wrong. Okay. Put all those in one of the categories. Go. You're on page 2. Put all of those in one of the categories. I know last block sucks. But be thankful it moves around. Right? I should dance for you? That's creepy, dude. That's weird. The Angry Bird will dance for you. No, some kid left it here and I just started playing with it. But it was a Happy Meal toy. It's one of the toys that makes me angry at McDonald's because this little bit of plastic is one extra nail in the coffin of our universe. McDonald's nobody needed to make this. This serves no purpose in the world except to ruin our planet because it was required fossil fuels to make it and it will never ever go away. So this little piece of plastic, it does. It makes me extraordinarily angry. It's made my kids' life very difficult because my kids are always like, Dad, can we get the toy that Happy Meal? No! Dad, I do want the toy that... No! I know, it's horrible, right? I don't let them have straws either. Because straws are the second most evil invention of humans ever. I hope so. They can't ban them soon enough. A straw is completely useless. Watch how easy it is to take a drink without a straw. I know it was empty, but shut up. The example is still there. Straws are useless and they are evil. My wife keeps saying, but we like to drink smoothies with straws. I think, go and buy some permanent straws. So she went and bought some metal straws and a little brush to clean them. I'm still mad, but what are you going to do? It's a loophole. I do like those bamboo straws that disintegrate. They're cool. Bamboo is awesome. Bamboo is my favorite thing in the world. Huh? All of bamboo. Everything about bamboo is awesome. It's renewable. It's grass. Doesn't hurt the world. Biodegradable. You can beat people up with the sticks. You can build scaffolding with the sticks. You can build a whole house out of bamboo. Beat people up with a bamboo stick. One poor guy, not a rich guy. Oh, okay. You guys got this done yet? Holy crap. It's already 1:47. Time sure flies when you're having fun. Right, Heyman? Yeah. Damn right. You comfy there, Tira? Parneet won't bite, you know. You can use the desk. Oh my God, Parneet, you've been to Ocean Shores? I go to Ocean Shores all the time, where I go surfing. That's so cool. Isn't Sharky's wicked? I love Sharky's. Parneet is mad because I'm singling her out right now. I love Ocean Shores. It's my favorite place in the whole world. You go there often or just once? Only once? I see. Did you play mini golf? You didn't play the mini golf? What'd you do in Ocean Shores? If you didn't, do you surf? So you went to Ocean Shores, you didn't surf, you didn't play mini golf. What'd you do? You went bowling? Yeah, it's a good bowling alley. Yeah. What else? Oh, the go-karts are fun there. Did you go on the slick track where they spray down the water so you can do total Tokyo drifts? Oh, you didn't? Oh, that's so wicked. They spray water on the track so you can super drift on the tracks. They don't let little kids do it. You got to be 16. Well, then, when you go to Ocean Shores, Ayaka, you can do drift track. Go-karts, what else? You went to the ocean? It's cool there, right? Did you drive on the beach? Driving on the beach is so fun, isn't it? And then you see those idiots whose cars get stuck on the beach, and you're like, ha, moron. It's true. The tide comes in, and people lose their cars in the beach all the time. Because once the ocean hits the hard sand, it's too soft, and the cars sink in all the time. And then you always laugh. Until you get stuck, and then you're like, ah! But I've never been stuck, because I'm not an idiot. That's so cool. I'd tell my kids, they'll be so happy. Nobody knows where Ocean Shores is. It's in Washington. This is the bomb bird, right? I've never even played. All right. What's the first one? Irrational. Abso-smurfly correct. What's the second one? Natural. Because, of course, the square root of 25 is 5. What's C? Rational. Why? It ends. Right? Even though it doesn't repeat, it stops. What's D? Natural. Because, of course, negative 2 to the fourth power, a positive exponent that's even with a negative base makes a positive number. That is, of course, positive 16. What about E? Natural. Now, if it's a natural, does that automatically make it a whole number, Heyman? Yes. Kind of. What about this? It's a trick, because it's not irrational even. Nope. That one is imaginary. That's the one that doesn't exist. You can't have a square root of a negative number. Until you're in third year physics and second year calculus. Then all of a sudden these imaginary numbers will be very important to you. But up until then, they're imaginary. You can forget about them. But then all of a sudden in second year of university, they're going to say, learn your imaginary numbers. You're going to be like, what? I've spent 12 years learning the real numbers. Why do I got to learn the imaginary ones now? But you will. If you go on in math. You don't have to go on in math. But if you do, you're going to need to learn imaginary numbers. And it's not like Snuffleupagus on Sesame Street. They're not going to actually show up and meet everybody. They will always be imaginary numbers. If you don't know who Snuffleupagus is, I'm sad for you. What about G? It repeats, but those dots mean what? It continues on. Do we know that the 75th decimal place might not be a 7? We don't know that, do we? So as it's written here, we could say it appears rational. But can we say for sure? No. What if those dots are gone? Then is it rational? What if I change those dots to a line? Is that rational? Yes. Good. Oh, wow. Everybody's so smart. I know why. It's because a great many of you had a wonderful grade 10 math teacher. I don't want to say who it was. I know you didn't. I feel sad for you, Heyman. But don't worry. You'll get grade 11 teacher. That's super awesome. You'll be okay. All right. Put a tick in every one that applies. A tick in every one that applies. So you don't just have to know one. You got to know them all. And then we're going to give a score. And the highest score is going to get a gummy bear. Except they don't have any gummy bears, so it'll have to be an IOU. I forgot to buy gummy bears yet. The highest score gets a gummy bear. Don't guess, because if you have a wrong tick, you lose a mark. You don't just not get credit, you minus a point. Are we ready? If you're not in the competition, you don't need to pay attention. But if you want to win the 5 gummy bear prize, then you got to follow along. How many ticks in 3/4? Just rational. That's worth 1 point. If you all got it, you have 1 point. Where does 10 go? Natural, whole, integer, and rational. If you're missing any of those ticks, you subtract 1 from your total. So I got 5 so far. If you're missing one of those, what about square root of 81? Natural, whole, integer, rational. Nice. What about -2? Integer and rational. What about -1.5? Just rational. Nice. What about 0.215? Just rational. What about pi? Irrational. What about 0? Whole, integer, rational. 0.15155. Ooh. Irrational. 0.15155. Doesn't repeat. Square root of 3. Irrational. -8.1. Rational. -153. Integer and rational. 3.14. Rational. I didn't fool anybody because that's not really pi. 23/8. Rational. So if you got a perfect score, you got 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah?
I did, actually.
Huh?
Yeah.
1 off. You lost 1, Louis. What fooled you? 3.14. What'd you get, Jordan? You got them all?
1 off.
You were 1 off. What fooled you? 0.15515. Yeah. And nobody else was perfect? Aaron, you were perfect? You guys are going to take me to the gummy bear cleaners. I saw your hand, Heyman. You don't worry. Are you texting everybody about how you just won the contest? Because if you are, I'm taking your phone away. Yeah. Thought so. There you go. True or false? All natural numbers are integers. True. True or false? All integers are rational numbers. True. All whole numbers are natural numbers. False. Yay, you guys is brilliant. I'm so happy. I'm over the moon. Turn the page over. Let's get down to business. Now that we're comfortable. Everybody should remember how to do exponents, yes? What's the base? Base is 7. Some of you will recognize this as the exact same first page of your grade 10 integer section. Exponent section. Because exponents are done poorly. How would you describe to me what the base is? No. That's telling me what the base is in this case. How do you find the base? Jordan. The number that the exponent is multiplying. Okay. That works. What else? What if I gave you this, Jordan? Is x a number? No. So that works real well if I have numbers everywhere. But now I have this. So what's the base? X. So tell me how you find it. How do you know the base is x there? What is it about the way we write that you know the base is x? It's the big number. Okay, again, we're using number. That's a letter. We're getting warmer. The big thing. Okay. All right. Okay, so, Hey, now what's the base? Yeah, I got you there. What's the base? It's still x. How do you know? Now you're getting warm. What, Lucas? Yeah, it's the thing to the left. All right? My eraser stopped working. Oh, now earlier today, my computer, all of you that know my computer problems with these pieces of crap, today, you know what it started doing? It totally shut down, and it started beeping like a bomb. Not a word of a lie. The computer started going beep, 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 and then it started to speed up. Beep, 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 beep. And I was like, holy crap. I had to do work in 2018 on the board. Can you believe it? Look at this. I had to do work on the board. It's the 21st century. Anyways, back to business. The base is anything. And I'm going to highlight that because for some strange reason, people don't believe that the bases can be things other than numbers. It is anything to the left of an exponent. Now, I don't like defining things like that because if you don't know what the base is, you probably don't know what the exponent is. But it helps to see examples. 4x cubed. What's the base here? What's the base? No. X. 4x cubed. What's the base? 4x. Negative 4 cubed. What's the base? 4. Negative 4 cubed. What's the base? Negative 4. It is only what is immediately to the left, unless there are brackets involved. Does everybody remember that? Everybody who was in my grade 10 class told me they remembered that too, and then I gave them a test on it. Right, Jordan? Okay. What's the exponent? In this case, in this example, my exponent is what? 3. Describe it to me. It is anything, and I'm highlighting that again. Yeah. Now there's one word that describes up top and to the right. anything that's a superscript, which means it's up and to the right. That's what that word means. So what is the exponent to x minus 1? What's the exponent there?
2x.
Nope. 2x minus 1, the whole thing. And by the end of grade 12, you will know how to get a variable out of an exponent. Some of you already know, especially if you're from another country. The power is the whole thing, 7 to the 3. And we read that as 7 to the 3rd, which you all already know. But it gets a special name. Cubed is to the 3, and the other special name is squared. And of course, that's to the 2. Nobody else gets a special name. All of you should be able to fill that chart in about 30 seconds. I'll slide up a little. If you're done with the notes, fill in the chart. It should literally take 30 seconds, for which, of course, means I'm going to give you 2 minutes. Remember what evaluate means? That means a number with no exponent. You have to actually tell me what the value is, if possible. And again, some of you will recognize that. That is almost the whole chart from your grade 10 book. But again, even after learning it, writing a test, writing a retest, writing a final exam, even on the final exam, the worst section is still exponents. And I don't know why, because all of you understand it. I will be filling it in as well. Hey, Heyman, what color should I use?
Purple.
Nice. Second time you've left. Yeah, and? I sat here for the same hour and my bladder is 4 times as old as yours. I'll let you go today. Don't ask me to go twice tomorrow. I'll get it. Go for Myers. Yeah. Okay. Bye. Taylor. Go see Miss Mackenzie. Taylor, are you leaving my class? Huh? Is it a course change out of pre-calculus 11? All right, I'll let it go. What? In the wrong grade? All right. Everybody done? There they are. Make sure you check them over. Make sure you've done them right. Tricky ones are going to be highlighted. Watch your butt with that one. Watch your butt with that one. And of course, remember that this guy that I'm highlighting in yellow can be either the purple or the red. Everybody remembers this, yeah? I'm waiting. Just relax. Everyone gets so tense. Jazz Karn. Oh, is it? I didn't use my calculator. I was working in my head. Let's check. 4 y to the x 6. Oh, crap. It should have been 4,096. Thank you. But it still should be negative, because of that negative out in front. Everybody's all good? If you're not good because you haven't copied it down, then you're good. All right, now, last year when I did exponent laws, if you were in my class, of course, I showed you that how to do exponent laws with letters, and I used numbers first, and then I moved to variables, right? You're in the 11th grade now. 99 times out of 100, you're not going to be dealing with numbers. You're going to be dealing with letters. So I'm going to go straight to there. I'm going to go fairly quickly because you all already know it. Multiplying powers of the same base. X cubed, x to the 4th. That equals x, x, x times x, 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 which is x to the 7th. And of course, the shortcut is x to the m times x to the n equals x to the m plus n. That is what you need to know. Unfortunately, that simple fact, even if you think you know it, when I give you a test on it, people still screw it up. So, actually pay attention to it. X to the 4 over x to the 2. That is the same as x, 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 x over x, x. Of course, what happens there? That cancels, and you're left with x squared. And of course, the shortcut is x to the m divided by x to the n is x to the m minus n. The second exponent law that you all know. Again, I'm not spending any time with it because everybody is comfortable with those. The first 5 you should be comfortable with. The third one, x to the 3 squared. That is x, 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 x to the 3 squared. So you write it twice, which is x to the 6th. X to the m to the n is x to the m times n. Now, everybody should be very comfortable with those 3. They shouldn't have even needed review. Is everybody good? All right, let's make sure. You don't need to write these down unless you want to. What is 3x times 6x cubed? Nope. 18 x to the 4th. Okay? Again, this is the type of thing I'm talking about. When you get trapped in thinking of only the rule and not what's really happening, then you can make mistakes. Because remember, 3 is not part of this base, is it? Everybody good? Okay.
Is that a 4?
Yeah, that's a 4. Sorry. 4. What about this one? What is 12x to the 9th divided by 4x to the 7th? 3x squared. Lovely. What is x? Oops, I wanted to be doing this in red. What is x cubed y squared all squared? X to the 6th, y to the 4th. And the last one that screws up kids more than anything, 3x squared, y cubed, z squared, all to the 3rd. 27 x to the 6th, y to the 9th, z to the 6th. Everybody forgets the 3 cubed also goes to that 3. That is about the hardest. Oh, I lie. There's no, I'm going to stop there. Is everybody honestly comfortable with the exponent laws, the easy 3? Okay. Not Q, yeah? F, yeah, Heyman? Okay. Fraction base with an exponent. 3/4 squared. No, I lie. I want to do that with letters. X over y, and I want to do that black. X over y squared. What is that really?
X squared over y.
Right, because it's x over y, because that's the whole base, squared. Then x times x is x squared and y squared. Okay? No. That's why it works. I'm showing you why, and I'm making a big deal out of it, because when you have to put all 7 of these together, people screw up if they don't know why. So the rule is x to the y to the m. The exponent goes everywhere. So I'm going to slide over here for a quick example. 3x squared over 2y all squared. What would that answer be? 9x to the 4th over 4y squared. Because the 2 goes everywhere. Is everyone good with that now added in? Okay, we are building and I am happy. The exponent of 0 is an easy one. What is that?
1.
x to the 0 equals 1. Nobody has a problem with that. Till I do this. What's negative x to the 0? No. Negative 1. What is negative x to the 0? Positive 1. Why? Aaron, Danny. Why? Right. The negative here is multiplying this base. It's not part of the base. Here it is. Everybody cool? There's no way to do a red example of that. It's just, it is what it is. Everyone is good? And now finally, the negative exponent. And I've left a lot of room for this because it blows your people's minds. I do not know why. X to the negative 3. Can that exist? No. What's the base? X. The exponent is negative 3. The exponent tells you how many times you're going to multiply x by itself, right? You cannot do that negatively. It doesn't exist. And yet, this notation can exist. Because if I write this number, x to the 4 over x to the 7, what is 4 minus 7? X to the negative 3. So it has to be able to exist somehow. This is what it is. They all cancel, leaving me with 3 x's in the denominator position. 3 x's in the denominator position is x to the 3 on the bottom of a fraction. What number goes on the top? Has to be a 1. Because if it's a 0, that's 0. And that doesn't make any sense. This causes much grief. Because if I were to write this, 1 over x to the negative 3, what's that? The x to the negative 3 had to go to the denominator. What's going to happen here? It goes back to the numerator because it makes sense. Now, the problem that you people have is when I give you one of these. 2x cubed over 3y squared all to the negative 2. This is where you go, Look at all the other rules and see if you can remember how to sort this out. If you can't remember it through the shortcuts, you can follow all the rules. Is this a fractional base? So does that exponent go to everything inside? So if we're going to do this in the longest possible way, the first step, that exponent goes to everything inside, correct? So it's 2 to the negative 2, x to the negative 6th, over 3 to the negative 2, and y to the negative 4. Agreed? Everyone's cool with that? Okay. Can that exist? No. 2 to the negative 2, that 2 can't be there. So where does it have to go? Down there and become 2 squared. Can that exist? Where does it have to go? Up and become 3 to the positive 2. Can that exist? Right now. No. Where does it have to go? To the denominator. And can that exist? It has to go up. And now we can sort it out, because 3 squared is 9y to the 4th, 2 squared is 4x to the 6th. Now please notice there's a shortcut. What did that negative exponent do to this whole base at the end? reciprocates. It flips the whole base. And then you can change this to a positive 2, like we did over here. Everybody cool? Now, what if there was a negative exponent inside and I flip it? Does that guy change yet? No. Does everybody remember? You're going to do a crap ton of practice on this. The bell is going to ring in 1 minute. This takes 2 seconds. XY to the M is XMYM. Your homework tonight is page 8. Page 5 for you guys. Just page 5. It's 11 questions. You can do it, brother. Copy what?
Number 7.
Yeah.